And this topic is one of the most confusing topic in structure analysis. Okay, so we are going to look at shear stresses now. Okay, we're going to look at shear stresses. And if you were to look at your course textbook on the Beer and Johnson, so it's chapter 6.1 to 6.3. Okay. As I said, it's one of the most confusing topic in structure analysis. It's because there are rules that you have to apply, and these rules are critical. And I'm going to derive for you what those rules are. Okay. Now, before we go there, we are going to find out what is shear stress. So shear stresses are stresses acting parallel to the surface. Okay. So if I were to draw a an element, so we're going to construct an element now. So we're going to construct a 2D element. So likewise, we have our transformation. So this is X, this is a Y. So we construct element. So element, if we were to draw an arrow doing this now, right? This is the shear stress and the plane intersecting the x-axis multiplied by the direction of the force. Okay. So our the direction of the stress. So I'll write this out. The first subscript means the intersecting plane. And then the next one, the y over here that you see, the second subscript on the right, it means the stress acting direction. Okay. So for this case, over here, the top arrow over there is the shear stress acting on the plane intersecting the y-axis. Okay. So this plane over here that you see will intersect the y-axis, and the force down here or the stress down here is acting on the x-axis. And to achieve structure equilibrium, we know that the shear in xy is equal to the shear in yx. Okay. So on the other side, you have the stress acting on the other configuration. Right. Now, I'm not going to teach positive shear or negative shear yet. Okay, we'll leave that to later. But this is how the shear stress are acting. Now, if we were to view this now, if we were to view this on the 3D element now, so we're going to look at this in 3D element. Before I go into 3D, any questions so far? Nope, we are good. Okay, so if we look into 3D, right, we go into 3D. So in 3D, this is our transformation now. X, Y, and then we have our Z direction. Now we're going to draw a cube now. We're going to construct a cube. Right, so this is our cube. Right. So we are aware that this will be, this correspond, right, to a shear in the plane intersecting the x-axis multiplied by y-axis, and this will be a shear y-x. Then I'm going to draw a different set of arrow now. Okay, I'm going to pick a different color. I'm going to draw a different set of arrow. So I'm going to draw to this set of arrow. Okay. So that's our shear, and that is equal to what? The shear on the plane that I'm writing on now, right? So that plane intersect the z-axis, right? And the vertical direction of the stress is y, right? So this is equal to shear y, z. And then finally, the last one. So this is our shear direction, right? So on the face that I'm writing on, so this is shear in the plane intersecting the x-axis, and the stress is acting on the z-axis. So this will be equal to shear zx. Okay. So for the start, it looks confusing, but it takes getting used to it. So you need to know the first subscript. It defines the intersecting plane, and the second one is stress acting direction. That's it. Okay, for now. So I'm not, as I say, I'm not going to go into positive or negative shear stress yet. That we'll leave it for Mohs circle. Okay. Now the next thing that I would like to highlight over here. So far, anyone, any questions? Are we okay? As I say, it takes time to absorb this. Anyone, any questions, please? No? Okay. So the next thing that we're going to look at